45 degree, 90 degree rule for a right angle triangle suggests the length of hypotenuse of isosceles right angle triangle is under root 2 times length of each side of the triangle. Here the given triangle is ABC. Let's name this as A, B and C. It's always good to keep the naming conventions intact and name the opposite side of vertex A as small a. Let's write down. And name the opposite side of vertex B as small b. And name the opposite side of vertex C as small c. Once this is done, now let's take a look at special angles. This angle is 90 degree because this triangle has to be a right angle triangle, so one of the angle has to be 90 degree. The other two angles for this triangle are given that they are 45 degree here and 45 degree here. 45 degree here. Now we have learned a very interesting result about triangles, that sides opposite to equal angles of a triangle are also equal. Since sides opposite to equal angles of a triangle are equal, therefore if this 45 degree and 45 degree, then both of these got to be B is also equal to A, because the angles are equal. If angle at A and angle at B are equal, then both sides opposite to angle A and side opposite to angle B must be equal according to this result which we have derived already. If that is the case, then by using Pythagoras theorem, Pythagoras theorem. What is Pythagoras theorem? Pythagoras theorem states that hypotenuse square is equal to base square plus perpendicular square. Now here C is the hypotenuse, so this is hypotenuse, this side is base and this is perpendicular. And if we use just this result, what we are going to get is C square is equal to A square plus B square. But we know that B is also equal to A. Since B is equal to A in length, again for the reason of two angles being equal, C square will be equal to A square plus A square. This means C square is equal to 2A square. And if we take square root on both sides, take square root on both sides, what we get is C equal to under root 2A. This means that for this triangle, C would be equal to under root 2A, where A is length of both equal sides of the right angle triangle, for which the angles are given 45 degree, 45 degree and 90 degree. So this in fact proves our result that length of hypotenuse of isosceles right angle triangle is under root 2 times length of each side of the triangle. Here the length of each side of the triangle was A, and the length of hypotenuse is under root 2 times the length of side of the triangle. Let's take a look here on this example. Suppose you are given a right angle triangle like this. Let's say that this is the right angle triangle A, B and C. You are given that this angle is 45 degree, this angle is 45 degree and this angle is 90 degree. And here it's given that this is equal to under root A. Find the missing, okay, this is given as A, we don't know. This is equal to C, we don't know. And this is equal to B, which is given. Of course, the Pythagoras theorem will not work because the base is not given, the hypotenuse is not given. There is only one side that is given. So we should have some additional information. We'll take advantage of two angles being equal, and then for that reason this special ratio of the lengths of sides of triangles. Now by using 45 degree, 45 degree and 90 degree rule, these both sides will be equal. So A would be equal to under root 8 as well, because these both sides must be same, because their angles are same, because angles opposite to sides are same. So that is the reason. And now when we have this as under root 8, according to the law, according to the rule, this hypotenuse must be under root 2 times. Hypotenuse is equal to under root 2 times length of side. And what is length of side? That is under root 8. So this is equal to under root 2 times under root 8. And if we take factors under of 8 times 2 times 2 times 2 and then make pairs under 1 square root, this would give us 2 times 2 times 2 times 2. So out of this pair and out of this pair, this will be 2 times 2. This will be equal to 4. So for this triangle, the length of the hypotenuse must be equal to 4. So you can see that three results are key. One, Pythagoras theorem. The other one is 30, 60 and 90 degree rule. And the third rule is this, which is 45, 45, 90 degree rule. These rules are going to help us in finding the unknown lengths of right angle triangles, and we will learn trigonometric ratios as well to help us finding the missing variables are missing lengths and missing angles in a right angle triangle.